Hi everybody, today we're going to be doing the Enthalpy Lab, and to get started with the Enthalpy Lab you are going to want to write and balance the equations that are listed in the pre-lab activity. So you have three equations to write and balance, and you can read through that. The first equation is solid sodium hydroxide dissolves in water to form an aqueous solution of sodium and hydroxide ions, and that's going to be our first reaction we measure the heat evolved from. And then our second reaction is going to be a solution of aqueous sodium hydroxide and hydrochloric acid react to form water, an aqueous solution of sodium and chloride ions. And so we're going to get that going on as well. That'll be our second reaction we measure the heat of. And then our third reaction, solid sodium hydroxide reacts with aqueous hydrochloric acid to form water in an aqueous solution of sodium and chloride ions. So we're going to be doing the three reactions. And what we are trying to do is we're going to show how reaction 3 is actually a combination of reaction 1 and 2. So this is going to go along with Hess's law. So if you have not done the Hess's law notes and the Hess's law problems yet, this lab is going to be really difficult for you to understand what to do. So you might want to go back and do those. So go ahead and pause this right now and set it up so that you have all three of your equations written and balanced. Okay, so our first reaction is going to be the one where we are using the solution or the water, and we're putting solid sodium hydroxide into the water. So my first thing I'm going to do is I have measured 100 milliliters of water, and I'm going to go ahead and pour that into my styrofoam calorimeter. And you'll notice on the screen here that my temperature is changing, and I'm going to go ahead and get that started for taking the temperature. Okay, so I am starting my temperature probe right here. I'm going to click the collect button. It is going to start graphing my temperature. To this, I'm going to add, and you might notice the starting temperature is 20.3 of the liquid. And to this, I am actually going to add 2.185 grams of the sodium hydroxide. So I'm going to go ahead and add that in to my liquid, and I'm going to use my thermometer probe to stir, and I'm going to stir and stir and stir while this thing is beginning to react, and we're going to keep stirring and keep letting it react until we get all the way to the end of the reaction. And what I'm doing is I'm simply dissolving the sodium hydroxide into the water, and that is going to give us the result here. So here we go. We're going to let it sit and make sure that it does not have any higher temperature. Everything is already dissolved in here. Oh, I do see a little bit, a few more particles in the bottom here, just making sure. It doesn't look like much, but let me change the scale here so you can see it. There's our scale, and it is plateauing out here at the end, and we're waiting for it to do that. So since our plateau is relatively flat now, and I'm going to change the scale one more time. Yeah, our plateau is relatively flat. We can honestly say that our highest temperature, we're not going to have to extend our lines and do anything because we do not have a dip in the plateau out here. So our highest temperature came out to 21.3 for this reaction. Okay, so this is going to be our second reaction then. I've cleaned everything up. I'm going to go ahead and pour in my 50 milliliters of 1 molar hydrochloric acid. So there is my 50 milliliters of 1 molar hydrochloric acid, and I'm going to go ahead and start taking that temperature. I'm going to click collect, and this time I am not going to, I'm not going to append to latest. I'm just going to store latest run. And I'm going to go ahead, that means our new run will be in blue. So right now it is taking the initial temperature, which is sitting at 19.7. Our initial temperature is sitting at 19.7. Okay, so if that's the case, and I'm going to go ahead and change my scale, there's my initial temperature at 19.7. And to this, I am going to add 50 milliliters of the 1 molar sodium hydroxide. So there is not a mass of this because we're adding 1 molar sodium hydroxide solution. So here we go with this, and our reaction, that one goes straight up, as you can see. I'm going to let that stir around for a bit. The reason why it did that is because we added it all in a solution, and I'm going to go ahead and change the scale while it's thinking there. There's our scale, and we're getting quite a difference in our reaction. And you might think about, well, why is that difference in our reaction happening like that? And this had to do with a difference in the states of matter of your reactants. In the first reaction, we had a solid being dissolved in water, a liquid. So we had the dissolution going on. This one was both two chemical reactants that were both aqueous. That means the ions are both in solution already. And as you can see, and I'm going to go ahead and stop the collection of data, as you can see that the ions in solution there were already ready to react, and so they went ahead and reacted immediately. The highest temperature here looks like it got to 26.4. The highest temperature got to 26.4. The lowest temperature, this is for reaction 2, was 19.7. Okay, so we're going to move on now to reaction number 3, and this reaction is going to be the reaction between 100 milliliters of hydrochloric acid at the 0.5 molar value. So I'm going to pour that in, and I'm going to let the temperature equilibrate while I go get, okay, to that, I'm going to go ahead and start our temperature. Our starting temperature is beginning at 19.9 degrees Celsius. And so we're starting our temperature at 19.9. And let's see, close this. All right, and so we're going to go ahead and add to that 2.035 grams of sodium hydroxide. Again, that's 2.035 grams of sodium hydroxide, and this temperature is also going up and up and up. So let's go ahead and let that react. Letting it react. It is going up, as you can see, quite well. This is the picture in the green that you can possibly see right there. And we're going to let it completely finish reacting. And I think everything is dissolved now while it continues to react. It looks like it is starting to plateau off. And so I'll report to you the highest temperature we got to before we stop our temperature readings here. All right, looks like our highest temperature that we have gotten to is 24.4 degrees Celsius. And so that can be your final reading for your third step. Okay, so your job now is to complete the analysis of using the analysis question. So you're going to determine the mass of 100 milliliter solution for each reaction. Remembering we're going to use density as 1. You're going to calculate the Q's, and you're going to calculate the change in temperature so that you can calculate the Q. And to find the delta H, remember that it's equal to the negative Q. So all of these were exothermic reactions, if you remember. And then it tells you to use the results of step 4 and step 5 to calculate the delta H per mole of the NaOH in each of the 3 solutions. So your job is to see what you can figure out, and of course finish the conclusion question. So you have the analysis of the data, you have your conclusion questions to do, and you should also be making sure that you turn in the completed data table as well. And if you'll notice, the data table has places for you to write in all of the calculated values. So there's all of that for you to work through. Hope you have a great day. Bye, everybody.